Imagine that you are lying on your back on a vast green meadow during a quiet summer night with no breeze at all and only the constant chirping of crickets blending seamlessly with your own gentle breathing. The sky above your head is immensely expansive and pitch black like an enormous velvet fabric, and on it there are millions and even billions of twinkling points of light which are distant stars. Each of those points of light is not simply a star shining right at this moment, but is actually a message of light from a very ancient past, sometimes from millions or even billions of years ago. That light has taken centuries and millennia to travel across the immense cosmic void, slipping through stardust and through cold gas clouds to finally reach your eyes at this exact instant. You feel your heart beating a little faster because you suddenly realize that the past has not disappeared at all, as it is still vividly alive and eternally preserved within this vast universe. Now allow your mind to soar even further. What would happen if we could not only look back at the past through those rays of light, but also slightly open a door to glimpse the future, which are things that have not yet occurred? This sounds like a dreamy science fiction story, does it not, with spaceships speeding past the stars and shimmering silver time machines? But in reality, these revolutionary ideas originate from the genius mind of Albert Einstein, who was the great physicist with messy white hair and a kind smile, and who completely changed how we perceive the world more than 100 years ago. Einstein, through his special theory of relativity in the year 1905 and his general theory of relativity in the year 1915, demonstrated that time is not a straight river flowing evenly from the past through the present to the future as we usually imagine in everyday life. Instead, time is like a part of a gigantic four-dimensional structure called space-time. Picture space-time as a huge, solid and unchanging cake where the past, the present and the future all exist simultaneously, overlapping each other eternally. From this perspective, every moment in the history of the universe, from the Big Bang explosion approximately 13.8 billion years ago to the moment you are reading these words, and even to events that have not yet happened in the distant future, all of them are already encoded in the fundamental blueprint of the universe. There is no real difference between the past, the present and the future, as they are merely different slices within that block of space-time. This concept, known as the block universe theory, suggests that the entire timeline of existence is fixed and unchanging, much like a movie reel where every frame is already filmed and waiting to be played. The Big Bang, which occurred about 13.8 billion years ago, marked the beginning of this expansion, with the universe starting from an incredibly hot and dense state, cooler than any temperature we can imagine today, and expanding outward ever since. Scientists have measured this expansion using tools like the Hubble Space Telescope, launched in the year 1990, and its successor, the James Webb Space Telescope, which began operations in the year 2022, providing stunning images of early galaxies formed just a few 100 million years after the Big Bang. But how do we reconcile this strange idea with our real-life experiences? In daily life, we clearly sense time passing with the steady ticking of an old wall clock in the living room, the ringing alarm clock in the morning, or the feeling of tiredness as a long workday goes by. Throughout thousands of years of human history, from ancient water clocks in Egypt and Babylon through smooth glass hourglasses in medieval Europe to modern atomic clocks that use the oscillations of cesium atoms to measure time with accuracy up to 1 second in billions of years, humans have continually improved ways to measure time. We can calculate the distance between two events, such as the time it takes for a ball to fall from a certain height to the ground, with astonishing precision, erring by only a few billionths of a second. And we all agree on some basic rules. If you have a normally functioning clock set accurately, it will tick at the exact same rate as my clock, your friend's clock, or anyone else's on Earth. All of them will synchronize with each other, giving the same result when measuring the duration of an event like a 100-meter run. We also agree on the order of events, with rain falling before a rainbow appears, or the sun rising before birds sing cheerfully at dawn. These seem like unchanging truths, the foundation of our daily time experience, providing a sense of stability and reliability in a chaotic world. But then the speed of light, which is the unchanging cosmic constant of approximately 300,000 kilometers per second, confirmed precisely through countless experiments, from the Michelson-Morley experiment in the year 1887 to modern laser measurement, steps in and turns everything upside down. It whispers to us that those normal clocks do not always agree with each other. Imagine you are sitting in a modern high-speed train rushing at a speed close to light with transparent windows to look outside. The clock on your wrist ticks slower compared to the clock of a person standing still on the platform. It is not that the clock is broken, but due to time dilation, a phenomenon proven through experiments with atomic clocks on airplanes in the year 1971 by Haefel and Keating. In those experiments, clocks flown around the world on commercial jets showed measurable differences in elapsed time compared to ground-based clocks, exactly as predicted by Einstein's theories, with discrepancies on the order of tens to hundreds of nanoseconds. Furthermore, not everyone agrees on what happens at the same time. Think of a simple example to feel the subjectivity of the present. You and your close friend are watching an exciting live soccer match on television, with the living room atmosphere lively with cheers from the speakers and the smell of popcorn spreading. But your program is delayed by 1 minute compared to your friend's, perhaps due to slow network signals. When a beautiful goal is scored, your friend jumps up cheering immediately while you are still anxiously waiting with your heart pounding. For your friend, the goal moment is now, while for you it is still the near future. That out-of-sync excitement makes you realize the present is not a straight line common to everyone. Now scale this up to the cosmic level, where everything becomes wondrous and mind-bending more than ever. You are walking on a bustling city street with honking cars and the mixed smells of street food, and suddenly you bump into an old friend coming the opposite way. You stop, hug, and greet happily under flickering neon lights. At that exact moment, in the distant Andromeda galaxy, which is 2.5 million light-years from Earth, a massive spiral galaxy with hundreds of billions of stars observed clearly through the James Webb Space Telescope launched in the year 2021, an advanced alien civilization might be meeting to decide whether to launch an invasion fleet toward Earth. Those shimmering ships with glowing plasma engines ready to plunge into space. This is the Andromeda paradox, brilliantly pointed out by physicist Roger Penrose, who won the Nobel Prize in Physics in the year 2020 for his work on black holes. For you standing still on the street, the alien's decision might not yet be made, because light from Andromeda takes 2.5 million years to reach here. But for your friend moving quickly in the opposite direction at near light speed due to relativistic effects, their present could include the moment the fleet has already departed, rushing through space with imagined roaring engines. How can there be such a contradiction about an event that seems objectively real? Fortunately, this is just a thought experiment away for our brains to vibrate with the wonder of the universe. And if those aliens exist, we hope they are friendly, sending peaceful signals via radio waves, as the SETI project has been listening for since the year 1960. The search for extraterrestrial intelligence, or SETI, has used radio telescopes like the Allen Telescope Array in California to scan millions of stars for artificial signals, though no confirmed detections have been made as of the year 2025. The light from Andromeda and the hypothetical fleet will take exactly 2.5 million years to reach Earth, so the argument is not about what the naked eye sees, but entirely about which events different observers with varying speeds and positions consider to be happening in their present. This moment of realization leads us into a deep philosophical realm where the air feels thick with big questions. If the future is predetermined by unchanging physical laws such as the law of conservation of energy, Newton's laws of motion, or the Schrödinger equation in quantum mechanics, then where does our free will fit? Our daily actions, from choosing a cup of coffee this morning to major career decisions, are they just a play already written from the dawn of the universe, from the Big Bang, with temperatures in the billions of degrees and infinite density? Imagine you receive 2 job offers at the same time via pinging emails on your phone. One job in a bustling city with high salary and bright urban lights, the other in a peaceful countryside with fresh air and rustling leaves. You ponder with your heart racing from excitement and choose one. That feeling seems like a truly free action coming from the depths of your heart. But from the determinism perspective, that choice was unavoidable. It was shaped by every past experience: childhood joy in the countryside making you love nature, university education teaching you professional skills, a hobby of reading science fiction sparking a passion for exploration, and countless small factors like today's breakfast affecting your mood. Your entire life, from your birth cry to your last breath, is just the unfolding of a script programmed by the universe long ago according to unchangeable laws. The ancient question of free will versus a predestined universe becomes more tangled with the concept of superdeterminism, which is a radical idea in quantum physics. Superdeterminism suggests that not only are our choices controlled, but even scientific experiments such as the Young double-slit experiment proving the wave-particle duality of photons, or the Bell experiment testing inequalities in the year 1964 could be influenced by hidden factors from the universe's beginning. The universe cleverly hides its true nature, making us believe in free will while everything is pre-programmed like a gigantic computer program. However, many physicists and philosophers strongly oppose this. Quantum mechanics, with its inherent randomness through the Heisenberg uncertainty principle where position and momentum cannot be known precisely at the same time, suggests events are not completely programmed. Fundamental particles dance randomly, creating uncertainty. Modern neuroscience with real-time brain scanning technology like functional magnetic resonance imaging or fMRI from the 2000s provides fascinating clues. Studies show that even in identical situations such as choosing between two images, neuron activity in the prefrontal cortex and basal ganglia changes subtly, with brain regions interacting in flexible ways. This implies a level of unpredictability embedded deep in the biology of decision-making, like a whisper of freedom amid the noise of laws. Experiments by researchers like Benjamin Libet in the 1980s showed that brain activity precedes conscious awareness of decisions by about 300 milliseconds, suggesting unconscious processes initiate actions, though later studies with higher resolution imaging in the 2010s have revealed more nuanced voluntary control mechanisms. So does accepting a predestined or superdetermined future remove the motivation to live? Or does understanding the limits of free will bring peace, like a river knowing it flows to the sea? These questions challenge core beliefs about existence, about time, about our actions, making your heart warm with wonder or filled with inspiration to live fully in each moment. Despite being overwhelming, these concepts open windows into the universe's mysteries. We may not have final answers, but that very unknown invites exploration, like wind whispering through ancient trees. Frontier fields are bubbling with activity. Loop quantum gravity, developed by Carlo Rovelli and colleagues since the 1980s, suggests time could be quantized into the smallest blocks, about 10 to the power of minus 35 seconds, known as Planck time, not smooth but discrete like pixels on a screen. This challenges the traditional block universe where time flows continuously like a stream. Loop quantum gravity attempts to reconcile general relativity with quantum mechanics, predicting that at the Planck scale spacetime has a foam-like structure, avoiding singularities in black holes. Physicists are also exploring quantum entanglement, where two particles remain linked instantly even across billions of light-years, defying the speed of light, like twins sensing each other through space. And retrocausality in models like transactional quantum mechanics suggests the future could subtly influence the past within limits. These studies, updated through papers in Nature and Physical Review letters in the year 2025, could change the flow of time we are familiar with. Recent experiments in 2024 at institutions like the Perimeter Institute have demonstrated entanglement over distances of thousands of kilometers using satellite-based quantum networks, paving the way for quantum internet technologies. Even time might be an emergent property from basic interactions, not a fixed dimension, as in the theory from Eric Verland on entropic gravity from the year 2010. Einstein's ideas, superdeterminism, quantum time, force us to question the most basic reality. The universe is more complex and inspiring than we imagine, a grand symphony with billions of notes. Embrace this wonder, continue asking and exploring. The universe is an endless source of inspiration, leaving room for countless views on time. Do you lean toward the unchanging block universe, emergent time, or a completely different perspective? Share your thoughts so we can together weave the cosmic story even more brilliantly.